Okay. Hi, everyone. My name is Nikita, and today I'm going to tell you a story of how we started preventing defects in our team and what we called injecting quality. Okay, so since I'm going to use some real examples in my presentation, some real code examples, I have to put this in here. I work for Deutsche Bank Technology Center, and this is the code I'm going to use. Okay, so everything that I'm going to talk about today is the real process of how our team operates. We've come up with it by retrospecting our work every week and adjusting it. And only recently we switched to bi-weekly retros as we felt the process is stable now. But for anyone who's going to be encouraged enough to try something like this, I ask you to always retrospect and do changes in small steps. This is the key to long-term success. Okay, let's start. So if you Google the phrase software development lifecycle, you'll see a lot of images like this. A nice image, it's colorful, and this one actually I composed myself. The only issue with images like this is that it shows you it gives you a feeling that this is exactly how you should structure your process. And each activity is exactly what it should be. I mean, testing is about clicking through the product, and requirements gathering is about writing documents. As we will see, you can do it a bit differently. I started working at my current company about a year ago, and we happened to be the first Salesforce team in the company in Russia. And of course, when we just started, we heard a lot of complaints about different issues that are currently on the table. One of the most painful things were returns from UAT with comments like, "This is not what we wanted." I actually heard it a lot back in my consulting days, and I bet a lot of people do hear this too. So we decided to get it together and understand what is the reasons behind this. And so this is a list that we come up. One of the key problems to this UAT returns, as we understood it, were that requirements are being proxied to the dev team. So developers sometimes don't even understand what is the problem they're trying to solve. I think everyone has seen this picture of a tire swing where it has like titles like this is how the project was described, and this is how dev understood this and how it was implemented, and so on. Though the requirements misunderstanding is not the only issue. We also have some implementation defects, which slips a lot to EAT. One of the reasons for this was that QA process was separated from development. The integration happened only twice a week, which is extremely large, caused an extremely large feedback loop. And QA people often got overwhelmed by the functionality that's dropping on them. But the main problem with this separation is that inspection actually does not improve quality. The product is built already, and the quality good or bad is already in it. So instead of inspecting the product, we should do something in the development process. We should inject the attitude to quality into it. So this is what we thought, and let's meet us, at least some representation of us. This is our team. This is the initial state of our team. We had 5 developers, 4 had Salesforce background, 1 guy was migrating from Java. We had a business analyst, and we had 2 QA guys who were responsible for testing, obviously. But with the processes that we followed, we actually migrated to the state where we have 7 full stack engineers. And we do everything by ourselves. We do the requirements gathering, we do the design, development, testing, release systems, and so on. This helped us a lot to understand all the steps of this development of the software development lifecycle, and we managed to we managed to achieve the state of insurance, the state of being sure in our code, like almost 100%. So how we achieve this? We actually always work in pairs. We even have a large sign on our team agreements page that says never work alone. It means like all the engineers are working in pairs, do everything they do with two pairwise looking at the code. This is exactly what helped our QA people to start developing on Salesforce. That's what helped developers to understand the testing nuances and get the right attitude towards quality assurance. I really like pair programming because you always have someone to discuss a solution with, and the continuous code review also helped us to enhance the code review process itself. The continuous code review is basically when two people look at the code, and what we did after that on the pull request side of things, we do a call where we discuss the architecture of the solution itself. So a pair should defend their architecture, their solution in front of the whole team, and this actually leads to a more clear architecture, to better decisions made in during the development. And also this increases the collection. This inspires a collective code ownership. The collective code ownership in turn increases the buzz factor. So since we don't have any piece of code that only one person owns, we don't have any key man dependency. And recently there was a situation where a guy should have left for a couple of weeks urgently, and the work hasn't stopped. Actually, the workflow was not impacted at all. We just managed to keep it along with. We just managed to keep it up. And a little bit about the pandemic that is raging on. Obviously, it's easy to do pair programming when you sit together at one computer, but when we are doing, it's even more important when you are sitting at home. So the pair programming gives you the feeling that you are not alone, and you always have a person to talk to. And this is extremely important when you're sitting home alone. So these are just some tools that we used for pair programming, and this code screenshot shows a usage of it. Okay, so let's talk about how exactly we're working on the stories, where we inject the quality apart from the continuous code review. So first of all, everything starts with the requirements, obviously. When we get a new project, we always ask for expected business impact, just to understand why we're doing this, and the key stakeholders who we can address to understand the details of the project. We get requirements from stakeholders through any communication means, emails, calls, one-to-one conversations, and so on. Everything we hear, we convert to JIRAs and prioritize them often. This helps us make sure that we do only the priority items. And we actually don't add much details in JIRA at this point, at the point where we create it, because it's just as Scrum or other agile techniques teach us. This is just a placeholder for discussion. And we discuss the details when we get to the JIRA and when we start working on it. When we discuss the details, we always try to come up with an example of real use cases. These are turned into Gherkin scenarios. And the approach that we've taken, we tried different approaches, but what we ended up with, we describe an end-to-end flow because it clearly shows the problem that we're trying to solve and the business impact. The scenario describes what the system should do, though it should describe it in in a manner of not describing the system, but the real world. So let's take a look at some examples, how our approach evolved. So the first one, this actually a pretty early one. What we had here is that Rachel is creating a coverage request, and then the following coverage request should be created. This is a bad pattern because it doesn't show any value. It just shows that yes, I put a bottle on a table. The bottle is on the table. This can easily be done in the glue code. It can easily be done in the checks underlying the scenario. Also, we don't understand the clear business value, what it should do actually. Another example, what we have here is first we have a given something, and requester is creating the following coverage requests. So this is an action. This is not a setup of the background. And this is another issue that we found in our pull request. We sometimes, in our scenarios, we sometimes put actions where they don't belong. So we put them either in given or in then, either in background setup or in the assertions. This is not how it should be done. All the actions should belong to the when statement, to the where all the actions should live. Another issue here is that the when statement is actually split in two, while this is a single action. The approver is just goes there and approves the requests. This is also what we try to avoid later on. And so let's take a look at the better example. What we have here is John works in the firm and works with a specific client. When John leaves the firm, they should no longer cover the client, and a person should responsible for replacement should have actions. This is a very easy to read scenario and describes a real world. And what is more important, it is not tied to an implementation. We don't have any Salesforce ports, for example, here. We can easily replace the underlying system with something else or migrate it for one implementation to another implementation. We can, for example, if we're using tasks here as the actions to address, we can easily migrate it to a custom object or something like this. So once this scenario is written and both business stakeholders and we are happy with it, we're starting working on test automation. So yes, we do test automation prior to the implementation because we treat it not as a test activity, but rather as a design activity. Tests that are glued to the scenarios should describe the interface. Either it's a programming interface or user interface. The scenario documents what the system does, while the test shows how it is done, how to interact with it to make it work. And a little bit about how we do this. We don't use any clicking tools. We tried some of them, but they don't allow us to write stable tests prior to the implementation. This is sometimes a problem. I mean, not using clicking tools, which handle the updates, which handle the updates, the Salesforce updates. But we try to build everything on the data attributes. All the custom code, at least, is built on data attributes, custom attributes that we add to all the all the elements we interact to. This helps us solve a lot of problems with selectors changing, with selectors maintenance. For standard functionality, it's not the case, but we're trying to live. Another thing about the test automation is that we have basically two parts of it. The first is the tests themselves, and another part is the test framework that we've built. Tests are just simple template methods that call the test framework, while the framework is a product kind of product of its own. And it is well tested with auto tests. We really love tests, so we write them while we write tests. Okay, so once the test automation is done, sometimes we go back and refactor it, but not always. It is just not always needed. So once the test automation is done, we start the implementation itself. Our org is separated into log packages heavily. That gives us a clean understanding of the dependencies. And what is more important, we can easily use scratch orgs for development. Scratch orgs are much faster than sandboxes in terms of test run. So just yesterday, I had an issue where a sandbox tried to run my test for like a minute or so, while in scratch org, they ran in 5 seconds. This is, I'm not sure what causing it, but it seems like this is just how Salesforce works. And to encourage often scratch org creation, since they also degrade performance over time, we have a script, shell script that we can run to set up a new scratch org. It installs all the dependencies of the package that we're working on, uploads some data, assigns permission sets, and so on. So for the largest package that we have, it takes approximately 5 to 10 minutes to set up a new scratch org. I prefer to do it every day. Okay, once we set up the dev environment, we start doing the test-driven LWC development. We also depend here on the data attributes. We'll take a look at how they work a bit later. So this leads to both jest tests and end-to-end tests are tied to the same attributes, and we do really care about what we put in those attributes, just to make sure we don't change them often. We also developed a custom test library that we deliver as an NPM package, only internally at the moment. But you will see how what it does in some examples a bit later. Basically, we did it to reduce some code duplication and encapsulate usual checks. So let's take a look at some real code. Here we have a simple template, and you can see here this data test ID attribute that I was referring to. We migrate those attributes to these selectors. The green selector is actually the method of that library that I mentioned earlier. And in the test code, we only operate to refer a component. We only use these selectors that we define up front. So let's take a look. Here we have some tests, and you can see here how we use these selectors. And actually, this method should have child under the second arrow, or these two methods, get child and sprite and should have property equal, are also a part of our custom library. It just, as I said, encapsulates some basic checks into it. Like should have child, for example, just checks if the given component has a child with this selector. Okay, once we do the LWC, we start working on epics. We do it in this manner because LWC actually dictates us what we need for the front end. And only after that, we understand what we should develop in epics. We also do test-driven development. We really like this technique. And usually we develop a top-level method and mock all the dependencies as we go. So we develop a top-level method using tests, mock all dependencies. Then we start implementing the dependencies and mock their dependencies, and so on and so on. So this gives us a natural layering. And even if we don't do this, if we go this is the outside in approach. And if we do the inside out, when we start with the lowest layer, we always tend to mock the data layer, the selectors layer, because the database interaction is the most expensive one, timing-wise, when you run the tests. This heavy mocking, like we do, sometimes can lead to errors like field is not queried or something like this. To avoid this, we usually add 1 or 2 integration tests for top-level methods. And now I will show you, if you've never done the test-driven development before, I will show you an easy way, kinda, to start it. A life hack that we've used to build the test cases up front. So we had a story to prevent duplicates of records of some kind. We need to filter out fields by 6 records by 6 fields. 3 were required, 3 were optional. And first, what we did, we came up with a set of examples where these fields were populated in different variations. We used Excel to write all these test cases, and you can see here that for client and contact, we used names that look like constants or variables in Apex. So they are written without any spaces. They're written in like in a constant way. I mean, all capitals using underscores. This is done because we used this stuff to generate the code for using it in the real test. So we're implementing the duplication engine. So basically, we can write a matching logic in Excel. It's pretty simple, and we actually implemented. We came up with 32 test cases, which basically just looked for matches in the previous table. And from these, we generated code that encapsulates the test case. You can see here the NA, which basically means no match for in Excel, and this is what we generated in the Apex code. And when we had match, then we just put the number of that record. And when we migrated it to Apex, this is how it looked. So here we have 32 test cases that run like in a couple of seconds or less, and thoroughly test the duplication engine. Let's take a closer look at the simple test case. What we have here is a test case number, expected result, which is basically an order, a number of the record from initial state, from initial database state, which we typed to the mock data generator. We replaced it with a real data generator in the integration test, but there was only one integration test and everything else was built in mocks. And then we put the input data for a test case. So as you can see, it's not that hard actually. Okay, and after the test, after the functionality is implemented, it's time to integrate. I already mentioned the interview, the code review, where the pair defense solution, and it can be done in several calls. So, for example, first we do the scenario and auto tests, or partially implemented auto tests, then implementation, or even parts of the implementation. We encourage to do integration often, just to make it easier to review, to do the code reviews, and to check often that everything is working. So we merge, often we merge finished work, but core conditions to this is that it doesn't break anything, and the tests are green, and this functionality is not visible to the users. Then we run epics and just tests on each pull request before we merge it. This is common practice, I guess. And end-to-end tests, we run end-to-end tests only after the integration because they're much longer to run than epics tests. After everything is integrated, we also do a quick exploratory testing and just quickly visually check that there are no defects. If something comes up, it's not critical if the end-to-end test is green. We just create a JIRA and prioritize it along. Probably we won't even return after that. So what we've achieved, we have no returns from UAT. That was our main goal, and we did it. We interact with business closely, and we have an attitude to problem solving. And this is probably the most important thing that helped us in this case. We also do no manual regression because we have a lot of tests and they cover everything. And I already mentioned the boss factor thing that we have no k-mean dependencies. Also, it's really nice that we have this pair programming, and it inspires kind of natural team building where you just talk to people as you work. And it makes a really easy onboarding for new people. And the most important, we don't search for defects no longer. All these practices help our team to stop looking for defects. And it's a really cool feeling when you're so sure in the code, in the code that you developed. I had a story by a person who wasn't involved in a particular feature development, came to me and said, "Oh, I found the defect." And it turned out that was not really a defect, but a feature, and it was in the scenario, and it was really thoroughly tested and so on. And I was like 100% sure that this guy just don't know what he's talking about. And this feeling is, I wish everyone can feel this about their code, and I wish you to feel it. Thanks.